Hey guys, my name is Jesse, and I'm honored to have worked under the guidance of my mentor, Reed, for this research project. Over the past 5 years, I've had the privilege of sailing more than 6,000 nautical miles, in total across 4 oceans. This experience was obviously fun and opened my eyes to pristine coral reefs, beautiful clear oceans, but also to oil slicks and countless plastic islands. Seeing both was a wake up call and a first hand lesson to me personally on how urgent our planet needs clean, reliable power. Today I'm recording from Shanghai, China, a city whose energy demand rivals that of entire nations, and whose skyline reminds me daily of the stakes of the global energy transition. So now let's move on to my actual research. First, picture a nuclear reactor, small enough to fit inside a high school gymnasium, yet powerful enough to light up an entire town, all while emitting almost zero carbon. That's the promise of small modular reactors, or SMRs. Today in my presentation, we will go through 4 sections: the problem, the thesis, why SMRs, and the future of energy. So let's first go over the problem. These should not be very unfamiliar, as they're already very prevalent in our lives nowadays. First of which is energy inequality. Millions in underdeveloped regions lack reliable, affordable electricity, limiting economic and social development. Number 2, dependence on fossil fuels. Current energy systems in these regions often rely on expensive, polluting fuels like diesel or coal, worsening climate change and exposing communities to fuel price volatility. Lastly, infrastructure and grid limitations. Building large power plants and extensive transmission networks is too slow and costly for many developing nations, leaving them stuck with outdated or insufficient energy infrastructure. So, what does SMR do? My research asks a single guiding question: can SMRs decentralize energy production in underdeveloped regions, delivering safe, scalable, and sustainable power where fossil fuels and traditional nuclear power plants fall short? I argue they can, and that embracing SMRs is essential if we hope to meet both developmental and climate targets. But now you might be asking, why SMRs out of all the options? Well, SMRs hold a number of advantages, and among the few are flexible deployment, passive safety and reliability, and low emissions, giving it a small carbon footprint. First off, let's talk about flexible deployment. SMRs are built in factories and then shipped to site, reducing construction time from over 10 years to just 3 to 5 years. This also cuts costs by up to 35%. And because they are modular, regions are able to start small, with a 50 megawatt unit, and add capacity over time, avoiding the cost and risk of massive upfront projects. Next, passive safety. SMRs use natural circulation to cool themselves. No operator, no external power needed. In emergencies, the reactor shuts down automatically, which is critical for regions with limited technological support. Lastly, low emissions and a small footprint. An 100 megawatt unit SMR can prevent 2 million tons of carbon dioxide annually and fits on less than half a square kilometer of land, ideal for remote or space-limited regions. So, I guess what I'm trying to say is my research shows SMRs are not a distant vision, but a real practical tool for solving global energy inequality and climate instability. If you're interested in learning more, my full paper will be published in the upcoming issue of the Curio Journal. Dives deeper into the economics, safety, and global potential of SMRs. Thank you.